So we are doing equations and inequalities involving absolute value functions. So there's a format that it has to be set up in, and then there are set rules that go with being equal, greater, and less. So you have to make sure you're paying attention to your signs, your symbols, all of those things, because it's going to make a difference in how you set it up. So I want you to think about this. You know that the absolute value of 3 is 3. You also know the absolute value of negative 3 is 3. So the absolute value of x is 3. Okay? If the absolute value of 3 is 3, the absolute value of negative 3 is 3, then that means the absolute value of x, if it's 3, that means x can be negative 3 and positive 3. If you think about it in that format, okay? So the absolute value of any number will always be the positive value. So I can plug in a negative 3 here, and I still get a positive answer. Okay? Everybody remembers those rules. All right. If you have ax plus b equals c, and c is greater than or equal to 0, you're going to set up two equations. You're going to take what's inside the absolute value bars and set them equal to c, so you'll just set it up like it looks, and the negative value. Because if what's inside can be negative, then you have to set it up to being negative so you can solve for what number that's going to be. So let's go through and do a couple of questions where you can see that. So first off, you have the positive side and you have the negative side. So you're going to isolate the expression containing the absolute value. So everything that's inside the absolute value will be on the left. Everything else moves to the right. Okay? And then once you have it set up in that format where it's ax plus b equals c, you rewrite it in your positive and your negative form. So you'll write it in each form. You'll solve both equations, and you may get one or two answers. There will be a time where there are extraneous solutions, and that's going to happen when x is on both sides. Okay? So this happens when x is on both sides. So let's start off with a very simple form. So we are already in the form that we need to be. We are in ax plus or minus b equals c. So you're going to take the positive. So you have x minus 15 equals positive 23. And then you're going to have x minus 15 equals negative 23. So you have your positive side and your negative side. Solve each equation. So subtract 15 from both sides. So 23 minus 15 is, or sorry, not minus, add 15 to both sides, and you get 38. Add 15 to both sides over here, and you get negative 8. So I don't have to worry about extraneous answers here because x is isolated on one side. It's not on both, okay? So think about what this means. If you were to plug the 38 in, what is 38 minus 15? It's 23. What's the absolute value of 23? 23. It checks, right? Well, what if I plugged in a negative 8? Negative 8 minus 15 is negative 23. But what's the absolute value of negative 23? 23. So that's why you're able to get two answers. Okay? Understand? All right. When you are given this form, you have to move the 4 first because you have to get the absolute value on the side by itself. So you're going to add this 4 to both sides. So now I've got 2x plus 5, and the absolute value equals 9. Now that it's in the proper format, now you do your this or that. So we've got 2x plus 5 equals positive 9, and 2x plus 5 equals negative 9. You have to have your positive side and your negative side. So I'm going to subtract 5 from both sides. That gives me 2x equals 4. Divide by 2. X is 2. Subtract 5 here. On this one, I get 2x equals negative 14. Divide by 2. X is negative 7. Questions? All right, well, let's look at the next one. So this time we have 2 times the absolute value. So the opposite of multiplying by 2 is going to be to divide by 2. So you're solving these just like there were parentheses and not absolute value. You still solve it the same way, okay? So now I'm going to divide both sides by 2. So I get 3x minus 2, and that's absolute value. 14 divided by 2 is 7. So now I have it in the proper format. Now I do this or that. So proper format, then this or that. So we've got 3x minus 2 equals 7, and 3x minus 2 equals negative 7. So if I add 2, I get 9. So 3x equals 9. Divide by 3, and I get 3. Add 2 again, so now I've got 3x equals negative 7 plus 2 is negative 5. Divide by 3, x is negative 5 over 3. So they're really pretty simple. You're just doing the same thing that you did in Algebra 1. It's just now you have 2 sides. And of course, sometimes they'll make you add and subtract, then divide. Either way, it's still the same rule. So subtract 10 from both sides. So I've got 3 absolute value 2x plus 7 equals 27. Then you're going to divide by the 3. 2x plus 7 equals 9. Now I'm in the proper format. Now I do this or that. 2x plus 7 equals 9. And 2x plus 7 equals negative 9. 2x equals 2, x equals 1. 2x equals negative 16, x equals negative 8. So those are your 2 answers that will work for that equation, or that inequality, or that absolute value equation, whatever they give us today. All right, I'm going to subtract 7. What is the problem with the way this looks right away? There's a negative. Can absolute value ever equal a negative? No. So since it can never equal a negative, this one has no solution. Absolute value cannot equal a negative number. It cannot equal a negative number. All right. Now, if I add 5 to both sides, I've got 3 absolute value. Well, let me write the right problem down. 3 absolute value 4x minus 1 equals 0. Because if I subtract 5 from both sides, I just zeroed out. Okay? Now, there can't be, if I divide by 3, I've got 4x minus 1. It's still equal to 0, because if I divide 0 by 3, it's still 0. 0 doesn't have a positive and a negative side. Okay? Since absolute value does not have a positive or a negative side, you only have to do it once. Okay? Because there's not two scenarios. 4x minus 1 equals 0. 4x equals 1. X is 1/4. So I'm going to make myself a note. Do not need negative side when equal to 0. Questions? All right. On back. Notice now we have x's on both sides. Now we're going to need to check our solution because x is on both sides. So you will need to check your solutions. And you will check your solutions by plugging them back into the original equation. All right, starting with the first one. You're going to have x plus 8 equals 2x plus 1. Well, the only thing you did was drop the absolute value. But that's the positive side. Now you got to do the negative side. So x plus 8 is equal to negative parentheses 2x plus 1. You can't just do negative in front of the 2x. You have to do it in front of the whole thing. So drop the bars and put parentheses. Then solve them. So if I subtract x from both sides, I get x. And if I subtract this 1 from both sides, I get 7. So I see that x is 7. This is your basic algebra 1. Basic algebra 1. X plus 8 equals 2x plus 1 if you subtract x from both sides and then subtract 1 from both sides. Okay. Now over here I'm going to have x plus 8 equals negative 2x minus 1 because you have to distribute that negative sign to both parts. So I'm going to add 2x. Well, x plus 2x is 3x. Then I'm going to subtract 8. If I subtract 8, I get negative 9. So x is negative 3. So now that I have my answers, I'm going to plug them into the original equation. So remember, your original equation is what they give you. So I'm going to plug in, I've got 7 plus 8 equals 2 times 7 plus 1. Well, what's 7 plus 8? 15, and the absolute value of 15 is 15. 2 times 7 is 14, and 14 plus 1 is 15, and the absolute value of 15 is still 15, so that answer checks out. Now I've got to plug in the negative 3. So now I've got negative 3 plus 8, which is 5, and the absolute value of 5 is 5. Now I've got 2 times negative 3 plus 1. Well, 2 times negative 3 is negative 6, and negative 6 plus 1 is negative 5. The absolute value of negative 5 is still 5. So everything checks out. Both of my answers are good. Questions? All right, let's move on. So now I have 2x plus 12 equals 4x. So this is going to be 2x plus 12 equals positive 4x, and 2x plus 12 equals negative 4x. So subtract the 2x, and that gives me that x is 6. So now I'm going to subtract the 2x again. So now I got 12 equals negative 6x. Divide by negative 6, x is negative 2. So now go and plug it back in. Plugging it back in to me takes longer than just solving it, right? But if you don't check your answers, then you don't know if your answers are right. So 2 times 6 plus 12 equals 4 times 6. 12 plus 12 is 24. 6 times 4 is 24. The absolute value of 24 is 24. So 6 checks out. 6 is good. Plug in your negative 2. So now I've got 2 times negative 2 plus 12 equals 4 times negative 2. Well, 4 times negative 2 is 2 times negative 2 is negative 4, and negative 4 plus 12 is the absolute value of 8 is 8. Well, what is 4 times negative 2? Is 8 equal to negative 8? Does 8 equal negative 8? No. Having $8 and owing $8 are not the same thing. So this is false. So that means this answer choice up here is not going to work. This one is an extraneous answer. So since this is false, negative 2 will not work. Because you cannot be equal to a negative. I cannot be equal to negative 8. Questions? All right, let's move on. So I've got my plus side and my minus side. So if I subtract x from both sides, x cancels out, and I'm left with 5 equals 11. Well, this is false. So this is not going to happen. It's not going to work. So let's try the other one. X plus 5 equals negative x minus 11. Add x to both sides, I get 2x plus 5 equals negative 11. Subtract 5. And divide by 2. So I only have to check one answer because only one of them actually happened. Negative 8 plus 5 equals negative 8 plus 11. Negative 8 plus 5 is negative 3. Negative 8 plus 11 is positive 3. And since 3 equals 3, we're good. Questions? So remember, positive side, negative side. This or that. Questions? All right, let's look at D. So I've got 3x minus 4 equals 6x minus 5, or 3x minus 4 equals negative 6x minus 5. But your parentheses have to go around that second part. So 3x minus 4. Actually, I'm just going to go ahead and solve this one. There's no parentheses. I'm going to subtract 3x, and I get 3x, so 3x minus 5. Then I'm going to add this 5 over here. So if I add 5, I get 1 equals 3x. Divide by 3, x is 1/3. And then the negative side, 3x minus 4 equals negative 6x plus 5. If I add the 6x, I get 9x. If I add the 4, I get 9. So x is 1. So now we got to plug it in to see if it works. Do you see what I mean? To me, plugging it in takes longer. Especially when plugging it in looks like there's a fraction. So 3 times 1/3 minus 4 equals 6 times 1/3 minus 5. Well, 1/3 of 3, that cancels out, so that's 1 minus 4, which is negative 3. 1/3 of 6 is 2, and 2 minus 5 is negative 3. 3 does not equal negative 3, so this is false. So this one does not work. It's extraneous. So let's check the 1 and make sure the 1 works. 3 times 1 minus 4 equals 6 times 1 minus 5. Well, 3 times 1 is 3. 3 minus 4 is negative 1. And the absolute value of negative 1 is 1. 6 times 1 is 6. 6 minus 5 is 1. Check. That one works. Questions? All right. I am going to pick up at E here. All right, so if I rewrite this, I've got 4x minus 8 equals 2 times 3x plus 1. 4x minus 8 equals 6x plus 2. If I subtract 4x, I get 2x. If I subtract 2, I get negative 10. Divide by 2, x is negative 5. And then I'm going to do the same thing with the negative. 4x minus 8 equals negative 2, 3x plus 1. So 4x minus 8 equals negative 6x minus 2. Add 6, I get 10. Add the 8, I get 6. Divide by 10. X is 6 over 10, which reduces to 3 over 5. Now what do I have to do? Check your answers. So 4 times negative 5 is negative 20, and negative 20 minus 8 is negative 28. And the absolute value of negative 28 is 28. 2 times, see if I can write this correctly. 2 times the absolute value of 3 times negative 5 plus 1. So 3 times negative 5 is negative 15. Negative 15 plus 1 is negative 14. So this is 2 times negative 14. Well, negative 14 is really positive 14, and positive 14 times 2 is 28. Now I have to do the same thing with the fraction. Four times 3/5 minus 8 equals 2 times 3 3/5 plus 1. Well, 4 times 3 is 12, so So this is 12 over 5 minus 8. And if I want to add a whole number and a fraction, I need a common denominator. So I'm going to turn the 8 into something over 5. So this would be 12 over 5 minus 40 over 5, because 40 divided by 5 is 8. So this is really going to be negative 28 over 5, which we know is really 28 over 5. Now I'm going to do the same thing. So 2 times 9 over 5 plus, I'm going to turn that 1 into a 5 over 5. Are y'all comfortable with me doing that? Because 1 is really 5 over 5. So that gives me 2 times 14 over 5, which is 28 over 5. So that answer checks out also. So we are good with both answers working on this one. All right, last one. So if I do my positive, 3x minus 10 equals x plus 6, and 3x minus 10 equals negative x plus 6. 2x equals 16, x is 8. If you are comfortable moving 2 steps at a time, you can subtract the x and add the 10 at the same time, then do it in 1 step. 3x minus 10 equals negative x minus 6. Add the x, I get 4x. Add this, I get 4. So if I add 10 to negative 6, I get 4. So x is 1. All right, now plug it back in. 3 times 8 is 24. 24 minus 10 is 14. 8 plus 6 is 14. Three times 1 minus 10. Well, 3 times 1 is 3. 3 minus 10 is negative 7, and the absolute value of negative 7 is 7. 1 plus 6 is 7, and 7 equals 7. All right, so now looking at inequalities, notice there's 2 sets here. So you're going to have the ax plus b is greater than c, and then you have the ax plus b is less than c. So this is what happens, and this is what you have to pay attention to. You're going to set them up just like you did before. Ax plus c is greater, or ax plus c or plus b is less than. That didn't change. But when you do your negative side will change. Not only do you get the negative c, but you have to also flip the inequality. So the positive side will stay the same. Ax plus b is greater than c, or ax plus b is less than c. But when you do the negatives, they will flip. So remember, to flip the inequality, on the negative side. So flip the inequality on the negative side. So you have your positive setup and your negative setup. Everything else is the same. Okay? So let's go through and let's look at the first example. So we have solve for 2x minus 5 is greater than or equal to 3. So you're going to go 2x minus 5 is greater than or equal to 3, and 2x minus 5 is less than or equal to negative 3. So you have to flip the direction of your sign and then make the left or make the right side a negative. So I'm going to add 5 to both sides. So 2x is greater than or equal to 3 plus 5 is 8. Divide by 2. X is greater than or equal to 4. Do the same thing here. Add 5 to both sides. So 2x is less than or equal to 2. So x is less than or equal to 1. So now what does that look like? Because it says to write your solution in either interval notation, set builder notation, or graph. So I'm going to show you the graph. So you've got your positive and your negative sides. You've got 1 and 4 is your answers. Since this is equal to, that means you're going to have solid circles here. And then read what it says. X is greater than or equal to 4. So that means everything to the right of 4, because that's greater than 4. In other words, look at what direction your inequality is pointing. X is less than 1. So you go to the 1 and you're everything less than the 1. So nothing between 1 and 4 is going to work. Nothing between 1 and 4. So that means from negative infinity to 1 and 4 to positive infinity. And make sure you're using brackets on the 1 and the 4, because it can be 1 and it can be 4. All right. Next question. We have to rearrange this one and make it in the right format. So I've got 5 x 3x plus or 3 plus x, and that's going to be less than 20. Then I'm going to divide by 5. So 3 plus x is less than 4. So now I'm going to do this or that. 3 plus x is less than 4, and 3 plus x is greater than negative 4. You have to have the this or the that. So x is less than 1. If I subtract 3 from both sides, and if I subtract 3 here, I'm going to get x is greater than negative 7. So if I have my graph, I've got negative 7 and 1. Well, x is less than 1, so that means everything this direction. It says x is greater than negative 7, so that's everything this direction. So that means only the things between negative 7 and 1. So you got negative 7 to 1 is your answer. Everybody good? When you're graphing it, since there's no equal signs on either one of these are going to be open circles on the end of your graph. All right, let's do the last few examples and let's be done. All right. So we have a lot going on. So let's just move the 10 over first. So we have negative 3x minus 6 is greater than or equal to, subtract 10 is 27. Divide by 3, so now I've got negative 3x minus 6 is greater than or equal to 9. Now that it's in the correct format, I can do this or that. Negative 3x minus 6 is greater than or equal to 9. Negative 3x minus 6 is less than or equal to negative 9. So negative 3x is greater than or equal to 15. Divide by negative 3. What is about to happen? So this is less than or equal to negative 5. And then over here, negative 3x is less than or equal to negative 3. I'm dividing by negative 3 again, so now the symbol flips again. So there's lots of opportunities for the inequality to flip, so make sure you're paying attention. So what does this look like as a graph? So I've got negative 5 and 1. There are going to be solid circles here. It says x is less than negative 5. So where is less than negative 5? Well, that's to the left of negative 5. It's greater than 1, so it's going to be everything to the right of 1. Nothing in the middle. So we've got negative 5. Actually, let me rewrite that with the... So coming in from negative infinity to negative 5. And then I've got 1 to positive infinity. So there are the ways. All right, one more example, and then there's 2 special cases, and then we're done. All right, so let's subtract 14. And then divide by 6. So since I am not equal to 0 this time, I still have to set it up 2 ways. Because what happens when you set it up the negative way? You flip the symbol. So you got 3 plus x is greater than 0, and 3 plus x is less than 0. So you have your positive setup and your negative setup. So x is greater than negative 3. But x is less than negative 3. Well, what in the world does that look like on a grid? So draw your line. You got negative 3, that's the only number. It is going to be an open circle. I have everything greater than negative 3 and everything less than negative 3, just not negative 3. So negative infinity to negative 3 and negative 3 to positive infinity. But you cannot have negative 3 as part of your answer. All right, last 2 examples. So these are special cases. So solve it. 2x minus 1 is less than 2 minus 7 is negative 5. Can an inequality be equal to a negative number? No, because remember, an absolute value means it's absolutely positive, right? Well, if it can't be equal to a negative number, can it be less than a negative number? If you can't be equal to a negative number, you cannot be less than 1 either. So this is no solutions. Absolute value will never be less than negative. So if you think about what it looks like as a graph, just for a second. If I were to graph -5 down here, absolute value is always up top. So this is your y equals 2x plus 1. So the absolute value graph is never below the line. The absolute value graph is never below the line. The absolute value is never below the line. And then our last scenario, I've got x minus 2 is greater than -3. So x cannot be equal to a negative. Absolute value cannot be less than negative, but can it be greater than negative? Mm-hmm. Yes. So this is all real numbers. This is all real numbers. So absolute value will always be greater than a negative. And to get a picture of what that looks like, if I've got -3, so y equals -3 is down here. And then you've got your graph here. It will always be above the line. So the absolute value graph will always be above the line. So those are your two scenarios. If you're less than a negative, there's no solution. If you're greater than a negative, it's all real solutions. So no matter what you plug in, it's going to work. No matter what. And that is it.